Hello everyone, welcome again to your study part, a place where we ensure quality and best education is given at an affordable rate. So here is it. We are getting ready into launching ourselves into acquiring knowledge this afternoon. And for benefits of doubt, ensure you have your pen and paper with you because you have a lot of things to jot down. From the previous knowledge of what you have before, we're actually making some modification to our ideology about certain topics with regards to wave. So this afternoon, we are looking at wave as a topic. Let's get right on. I'm sure we can all hear me. Um, okay, the first person has indicated. The second person, Mr. L, can you hear me? Mr. L, your name? Okay, beautiful. Then Mr. or Mrs. F. Okay, perfectly well. That's good. So today, we want to highlight something with regards to wave, and that's with regards to this formula. 1 over F equal to 1 over U plus 1 over V. I'm sure we are all familiar with this topic, isn't it? This formula, right? Good. Now, I have a simple question which quickly I'll appreciate us helping me to solve. Give it your best shot in record time. Remember, I told you that preparing for your JAMB examination, try as much as possible. You have 40 seconds to play with any question given to you. So I'll be throwing the question at you and I'll give you just 1 minute. So I'm sure you have your calculators with you in case you'll be needing calculator to solve it. So let me see what we are going to have as your final answer. Here is the question. Quickly, the people on the platform at the moment, give me your best shot. A simple question under mirrors. The question is this. Is this better? Okay. Please, for those just joining us, I said that we'll be looking at an aspect of wave today, making reference to our concave mirrors and convex mirrors, with the other names diverging mirror and converging mirrors. But here is it, a misconception as regards using this formula above to calculate. I want to see how many of us are actually what? We've grounded ourselves in creating a distinction in the application of this formula. So the newcomers in the house, those just joining us, endeavor to attempt this question quickly in record time. You have only 1 minute to attempt the question. Then we'll now discuss certain things. So here is it. A convex mirror with focal length of 50 centimeter produces an image of 20 centimeter away from the mirror. Full stop. Determine the object distance. Determine the object distance. Quickly. Everyone on board, give it a shot. I need an answer to this guy. The focal length of the mirror is given to us. Similarly, the image distance is given to us. What would be the object distance? Let's have a shot to it, so that we are sure that we have the right formula and we're using it the right way. I just hope many people would not miss out on this, such that they don't join too late. Quickly, 1 minute, 1 minute, 1 minute. Be getting ready to stop. 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 All right, stop everybody. Let's have our answers. Yes, first person. First person, what do we have? Mr. L, what did you arrive at? I can't seem to hear you. 0.07, all right. The next person, all right, noted. 0.07. Mr. or Mrs. F? Miss F, any answer? All right. Mr. or Mrs. A? Okay, let me have your answers. Let me have your answers randomly, quickly. I can't hear you. You said? Okay, okay. Quickly, please. But remember, we have just 40 seconds for every physics question. Don't forget that. 40 seconds. And please don't lie against me. Remember, I'm not an English teacher. I didn't give you a formula for you to use. I only brought this so that you know which aspect of the topic I'm talking about. That's why I wrote this formula, which I circled. So don't say, sir, you're the one that gave us the formula to use. I didn't give you any formula. I want to see what you know about the formula. So quickly, what is the answer? So that when we are now revising this aspect, you are well grounded on what exactly you are to do, what exactly you are to take note of when you are calculating questions regarding F, U, and V. F, U, and V. Quickly. F, U, and V. Our time is fast spent. Let the answers be pouring in. Give me your answers now. My people, my people. My people, my people. JAMB is in less than 30 days' time. Yes, your answer is? All right, we have an answer, 33.33 centimeter. All right. Any other answer before we proceed? Any other answer on board? Okay. So here is it. Let's get into the business. We talk about curved mirrors. Curved mirrors. Or you talk about spherical mirrors. Spherical or curved mirrors. Spherical or curved mirrors. They have two specific types. It's either we are talking about concave mirror or we are making reference to convex mirror. Concave mirror, or we are relating with respect to what? Convex mirror. Here is it. We said there are two types. There are two types of curved mirrors, namely a concave mirror, also known as converging mirror. Now we have the second one, known as convex mirror, which we also know as diverging mirror. As far as these two guys are concerned, It's majorly about the type of images that they produce. The JAMB would ask you, to a large extent, 99% of the time, JAMB does not have any business asking you, what is a concave mirror? Or what is a convex mirror? They don't care about that because, to a large extent, it is not needed. It's not the definition they are what interested in. Rather, they are interested in what? Images formed by these two guys. Check it out. Concave mirrors now. Concave mirror. We say that any day, any time, we are making reference to what? Concave mirror. I would note this aspect. These are my answers, and the question was such that focal length was given as 50 centimeter, and our image distance was given as 20, so that I can have space to write. I can have space to write. So I'll be cleaning this aspect. So here we go. We say that for concave mirrors, they are actually mirrors that produce what? Images that are concentrated, isn't it? You have that what? They are mirrors rather that produce what? Diverging images. Images that are what? Tend to diverge along a given what? Range. Now, that is not the context, the major context of what we are driving at under this aspect. Rather, the major aspect we are driving at is about these guys. Let me write it here. Images produced by concave mirrors. Images produced by concave mirrors. This is where we are driving at. Images produced by concave mirrors. And here is the catch. Your textbook has written plenty things and plenty diagrams for you, which you will see 2F, F, principal axis. When the object is positioned at this point, it produces images and everything. They've created plenty things for you. But there's a summarized way of remembering these guys, such that even when you get to your university, your first year in the university or in the polytechnic, this principle I'm giving you would apply flawlessly, without wahala. Check this out. To remember exactly which position these images are formed, I start by giving us our concave mirror. How many of you are familiar with this diagram? You've seen a curved part and a line there. Now, check it out. Everything about images produced, there are just 5 images they want you to be familiar with. Only 5 types of images that are produced. And the positioning of those 5 objects are such that they follow this alphabet. You have alphabet C, alphabet F, and alphabet P. Alphabet C, alphabet F, and alphabet P. 3 alphabets we are working with. Now, the positioning. We have position number 1. We have position number 2. We have position number 3. We have position number 4. And lastly, we have position number 5. These are the 5 positions they will everly give you, even up to your university level. 5 positions only that they are interested in. 5 positions, nothing more, nothing else. Now, C stands for what? Students of the high order of physics. Yes, what does C position stand for in terms of our labeling? Anybody in the house? C represents what? Or maybe the question I should have asked is, how many of us have been taught this topic? So let's start with that. Just give a response. I've been taught this topic. Give a response. Give a response. I've been taught this topic. Can I hear from you? The image is formed by a concave mirror. Okay, one person. Only one person. Center of curvature. Thank you, Ma. Any other person? I've been taught the topic already. Okay. Okay, beautiful. Now, then you should be familiar with the fact that your C represents your center of curvature. That's what we call it. Center of curvature. Center of curvature. The F is representing your focal point. The focal point. Your P is representing the principal focus or axis. Now, listen. It's either the position and objects at point 1. And what name do we give to point 1? We said that what? Object position. What you must note, the object position, you must be familiar with where the object is positioned. You must be familiar with the image position. And you must be familiar with the third thing, image property. Image property. Those are the 3 aspects of concave mirror or convex mirror they are going to be asking you. 3 major things. The object's position. When they position an object somewhere, where would the image be formed? If the image is formed, what type of property is the image going to have? Now check it out. Number 1 position, I'm sure you can see the board. Number 1 position is saying that you are positioning the object beyond alphabet C, meaning you are positioning it beyond the center of curvature. Anytime you position an object at position 1, which is beyond alphabet C, meaning beyond the center of curvature, where is the image going to be formed? The image will be formed at number 3 position. At number 3 position, and observe closely. Number 3 position is between which alphabet and which alphabet? C and F. Number 1 produces an image between C and F. Number 1 position of the object produces an image at number 3 position. What type of image are we now going to get? We call it MIR. MIR. What does the acronym MIR stands for? We are making reference to a magnified image, an inverted image, but R stands for what? A real image. The image positioned is MIR. What is the acronym of MIR? Magnified, inverted, real. Check out the second one. Number 2. How do you want to remember this? CFP, alphabetical order. CFP. C comes before F, F comes before P. CFP. Just put your number 1 to 5 in between them, slash them between them. Number 1 is before you get to C, beyond C. Number 2 is exactly at C. Number 3 is between C and F. Number 4 is exactly at F. And number 5 is between F and P. Those are the only 5 positions they can ever ask you. Now check this out. Number 2. When the object is positioned at C, exactly at C, when you have your object positioned at C, where will the image be formed? Don't stress yourself. 2 will produce 2 again. It will be formed exactly at C. Your image will be produced exactly back at what? Number 2 position. Such that the image formed, we call it SIR. SIR. What is SIR representing? Same size. When they say something is magnified, it means bigger. Here now, same size. The image size is the same thing as the object size. You have I as being inverted, and you have R as being real. Number 3, position. Remember, when you position the object at C, beyond C, you have the image between C and F. Check it out. When you now position the object between C and F, when the object is positioned between C and F, what happens is that what? Number 1 is where the image will be formed. And this is what? Beyond C. When you put your object at position 3, the image will be formed at position 1. As such, what type of image do we get here? We get DIR. What does DIR stand for? Diminished image, inverted, and what? Real. This is the type of image you have for number 3 position. Number 4 position. When you have the image exactly at F, when you are positioned exactly at the focal point, then you say that the image position will be at infinity. At infinity. Don't stress yourself. No image property is given for this guy. At infinity. Once it is exactly at the what? Focal point, the image is formed at infinity. Then the final guy, number 5. Between F and P. When you position your object between what? Your focal point and the principal focus. Where is the image produced? Behind the mirror. Behind the mirror. And it is this guy that gave birth to the image property MEV. MEV standing for magnified image, erect image, but virtual image. Magnified, erect, virtual. These are the 5 types of images, even up to what? Your university standard. They don't change these things from here. The worst that would happen, the center of curvature, instead of giving you alphabet C, they will give you 2F. Because we know that the center of curvature is 2 times the focal point. So what you have inside your textbook, new school physics, and what you have here, they are not different. Center of curvature is twice the what? Focal point. And it is also known as the radius of curvature. In calculation, alphabet R will be given to you, which stands for the radius of curvature. It is also indicating your 2F, twice the focal length. This form the what? 5 positions for your concave mirror. 5 positions for your concave mirror. 5 positions for your concave mirror. Without much ado for nothing. Then you will agree with me that I can now enter the scope of calculation. We're told that what? Calculation under, good afternoon, ma. Yes, ma. Yes. Okay. Oh, really? My apologies. I sincerely apologize for that. I sincerely apologize for that. Was that during this, what are they calling? Was it during this JAMB revision? Is it this JAMB revision or? Okay, my apologies for that. My apologies for that. Then why didn't you mention it in the first instance that I've actually taught this part? Late. Okay. How many of you were actually in the class when I had this with you before? No, I'm asking the other participants. Others in the house, how many of you were around when I actually taught this?